Welcome, everybody. Thank you for being here for this fascinating and weird topic. I'm Marco, and today we're going to basically talk about how it's possible to access macOS native APIs in Compose Multiplatform with some magic and some workarounds. So why these things? Yeah, basically, maybe you are working with Compose, and you get a nice idea for a desktop app, because maybe you need a tool, maybe you need something that you want to have. But with that, you also want to go behind the JVM and access some native stuff. And we're going to see how it's possible to do so. So there's Compose Multiplatform. You may already use Compose for Android, but with Compose Multiplatform, you can also build for other platforms. Like, of course, still Android, you can build for iOS, you can build for desktop, and you can build for web. But specifically today, we're going to focus more on the desktop part and desktop macOS. And the story today comes from, it's not a made-up story, but basically comes from a real situation where I found myself, because I have a RSS reader app that I developed because I like RSS. It's an app called FeedFlow, built with Kotlin Multiplatform, Compose Multiplatform, Sweet UI, and it's available in basically all the platforms, on Android, iOS, macOS, Linux, and Windows. And one of the features that the app has is syncing the feeds, syncing the things between multiple platforms. And to do that, I'm using the Dropbox API, because multiple platforms, and the iCloud API. So one day, I got a 4-star review from a relatively happy user that was using iCloud to sync their data, and but it was working on iPhone and iPad, but on macOS, no, because iCloud was not available, and that wasn't a mistake; it was on purpose, because iCloud JVM, that's not something that it's not something that they talk between each other. So I was wondering, I was starting, 4-star, I wanted the additional star. So I started wondering, is this possible? Can I somehow go around the JVM and get iCloud working? Well, it was around Christmas time, so it was the perfect time for going into a Christmas rabbit hole, to just fill the Christmas time with some weird things. Luckily, I was able to came out from that rabbit hole, and basically the TLDR of this entire thing is using Kotlin native and the JNI. And we're going to see why and the things of why using that. Please don't run away after hearing JNI. But yeah, basically, what we're going to see today is how from Kotlin native and JNI, we can generate a dynamic library to have the code working on macOS, and then importing that dynamic library on the Compose Multiplatform macOS desktop app. And all of this also because I didn't want to use, I only wanted to use Kotlin for that, because I like Kotlin and I don't want to use something else in this case. All right, so, okay. So why we have to do that and not use something that the JNI offers? Well, because when you run your Compose Multiplatform app, you are running it on the JVM, and the JVM is running on your on the guest OS where you're running the thing. In this case, macOS. And since the claim is the nice bright ones run anywhere on 1 billion devices, then the JVM acts as a layer, and it provides the stuff that you provide the abstraction from the OS. So for example, if you need to access, I don't know, file system, things like that, what you do is going to the JVM, asking for the API that the JVM gave to you, and then the JVM is going to call the underlying OS for dealing with the things that you want to deal with. What you cannot do, at least directly, is just going directly to the underlying OS and ask for something, because there's the JVM that needs to run in multiple platforms, and you cannot go directly. But of course, this is not an esoteric scenario. There are multiple cases when you want to access native APIs, and there's a way, of course, that has been provided by the JDK to be able to do so. So, of course, spoiler: this way is the JNI, which stands for Java Native Interface, and basically is a way provided by the JVM to be able to run native code like C, C++ on the JVM, basically. And how the things works is basically that you define your methods on the JVM, and then the JVM will make sure to connect the dots and run something that is actually implemented on a native code. And it works. There's another thing that could be useful in these cases, which is the JNI, which stands for Java Native Access, which is basically a wrapper above the JNI, because JNI was not the best and the easy things to use, and so the community built a library around it to be able to run native code without having to write C code, basically. So the JNI exposed some methods, so you could write native code without writing native code, basically. And of course, since this is a sort of wrapper, there's some performance implication, because there's dynamic invocation and reflection in order to connect the dots, so it may come with performance issue. So you gain in developer experience, you lose a bit on performance. Depends depends about the things that you have to do. And then I discovered that there's a new thing that is called Project Panama, which is basically a new way of accessing the native code in the JNI, which is basically it's still in preview in the recent JDK, so it's supposed to improve the JNI, but it's still in preview, so I decided to just go with the JNI. Okay, so. After discovering how to go, I was ready for my little Christmas hackathon, let's say, and I started building a POC. And so I was, okay, I want iCloud on macOS, native code on macOS, or native code on macOS. Of course, it's Objective-C. So I started writing Objective-C, and yeah. It worked, because it worked. I got the URL of my folder, of my iCloud folder up and running, but writing this thing was not the most, let's say, pleasurable experience that I had. So of course, when you don't have a pleasurable experience, you go on social network complaining. And luckily, I had Kevin here, Kevin Halligan. We had a nice discussion, and he said, well, maybe instead of writing Objective-C, maybe you should write Kotlin native and then avoid writing Objective-C in 2025. Which I was, of course, why I didn't thought about it and went with Objective-C. Kotlin native is perfect. I also have code written on iOS for syncing with iCloud on iOS, so I can even reuse it. And yes, Kotlin native is perfect. Let's go with it. But before, what's Kotlin native? So if you never used or never interact with that, Kotlin native basically it's a technology to to be able to run Kotlin code in platforms that doesn't have a virtual machine, basically. So that means on all the Apple ecosystem, so iOS, macOS, watchOS, tvOS, and that's it. Not Vision or OS yet. I hope it will come, but not yet. And yeah, Linux, Android, the Android NDK, and Windows. So basically, with Kotlin Native, you have access to the platform-specific APIs. So it's a perfect fit for what I want to do. And you have access to native libraries because Kotlin Native is interoperable with C and Objective-C library. So you can consume such libraries from Kotlin, which is amazing because you just interact with Kotlin, and underneath you have the library that is doing what you want to do. And this is made possible by CInterop, which is a tool in Kotlin Native that automatically generates the bindings for the Kotlin bindings for the Objective-C library that you want. By default, there are some system frameworks that are automatically connected together, and the bindings are automatically generated. So those are, for example, the Foundation, or on iOS, UIKit, and basically the basic building blocks for building iOS or macOS API. And the system automatically generates that for you. So you can open a Kotlin file, import Foundation, and start using the native APIs. And this NS File Manager is basically, for example, an API in the Foundation framework where you can use, where you can basically interact with the file manager both on iOS and on macOS. And this is just the same, the naming is the same as the API that you can find on the Apple documentation, and that you will use on a normal iOS app. So, for example, you can, of course, import and use all the functions that are available from NS File Manager. So, in this case, URL for directory, which is a method to get the document directory the directory of the documents in the phone or in the file system of macOS. And this is exactly the same API that you could find if you are navigating the API on the documentation for macOS. Okay, and yeah, so since we are in Kotlin, we can just click things around, and if we click and jump into the definition, we can see actually how it looks like. So if you click, you can go inside. You're going to have a bunch of code, and as you can see here, there's basically the same naming with the same definition of the class that you're interacting. And then if you scroll around, you can find the actual definition of the method with the same parameters that this function wants. And of course, you cannot see the implementation because the implementation will be native code, so you cannot read it. So basically, for all the system framework and the system APIs that you need on iOS and macOS, those are automatically generated. But if you want something else and some other libraries, you're going to have to generate the binding. You're going to have to generate the binding yourself. I mean, not yourself, but you have to tell the machine to generate the binding for you. And yeah, in my case, since I want to interact with the JNI, I need to generate the binding for the JNI. Okay, so for generating the bindings, there's a way of doing that, of course, and you have to define a definition file. Yeah, sorry for the bad wording. So create a definition file sounds better. And this definition file is usually called with the same name as the library that you are generating the binding for. So in this case, JNI. And in the file, you're going to put the headers for which library you want to generate the binding for. So in this case, jni.h. If, for example, you're importing, I don't know, Firebase for iOS and you want to generate the binding for iOS, you're gonna write firebase.h or firebase crashlytics.h, and the bindings will be generated. So it depends on the library that you're using. In this case, it's just a boring JNI. And this file is placed inside, this file is placed inside a specific folder on the Kotlin native, module, which is native interop c interop. And you can put how many libraries you want to generate the binding for. Of course, it's not enough. You need some Gradle setup, because yeah, there's always some Gradle setup to do. And first of all, you need to tell Gradle which target you want. In this case, we are building for macOS and only for Apple Silicon, because yeah, Intel Macs are dead nowadays. So ARM64. And then you have to provide a name for the library that you're building for. And of course, iCloud, Kotlin, I had to put the K in the name, otherwise it wouldn't have been a valid Kotlin library without the K. Okay, so at this point, you need to, inside the cinterops blocks, you need to define the bindings you need to actually tell Gradle to generate the bindings. And to tell it, you need to create a new block and tell, first of all, the package that you want. So here you can put whatever you want. And this will be the package that you need to import in your file in order to interact with the library that you are generating the bindings for. And then you have also to tell Gradle where to find those headers, because Gradle doesn't know what you want to build the bindings for. So in this case, the JNI, the JNI and the headers for the JNI are inside the JDK that you have installed in your machine. So in this case, if you go inside your Java home folder, you can find it inside the long path that ends with the include, and inside here there are the headers. And then you need another headers, because the JNI header just include another header. So you have to provide that as well. Otherwise, things won't work. OK, at this point, with the include dirs, we told Gradle where to find the thing. We can sync the project, maybe take a coffee, and then the bindings are generated automatically for you, and you can start using that in the code. And another step that is missing for configuring the project, another little bit, and then we are over with the Gradle setup, is telling Gradle that we actually want a shared library to be generated. So in this case, we have to tell, OK, give me a shared library with the name iCloud. And that's it. We are done with the setup, and we can start finally writing some code that has something, and it's not just infrastructure code. OK, so let's assume that, let's keep it simple and pick a simple example. So let's assume that we want to upload something to iCloud in this case. And so we just create a simple upload to iCloud function. We need, however, some parameters that are JNI specific and that are required for the JNI to work. I don't need those in my code. We're going to see it, but you need to provide them. And basically, the first one is a pointer to the JNI environment, which is basically a structure where there are other pointers to the methods that you can use to interact with the JVM inside your code that is not running in the JVM. So, for example, you can get stuff to, I don't know, instantiate new things, handle exception, things like that. There are different stuff that in this case we don't need at all. And then there's another parameter that is a reference to the class that will basically include this method, and it will be the class that we are going to use to interact with this method. But we're going to see it in a moment. Again, it's a method. It's a necessary method, but we don't need that, so you can ignore it. Okay, let's start writing some code. So in this case, we want to upload our database file, which in this case is a text file for simplicity, but yeah, don't use a text file as a database. But so in this case, the first thing that we have to do is get in the URL of this file, and basically on the iOS, the Apple APIs works with URLs, so we get the URL of the file on the file system, and then we can deal with that. Secondly, we need basically the destination URL, so the URL for iCloud. And we can get the URL from iCloud, again, using the file manager, DNS file manager. First of all, we need to get the URL for our container of our app, which is assigned to our app in the iCloud storage. And this identifier is an identifier that we created on the Apple console, basically. And then you can just get the path of the documents and then the path of the file where you want to save it. And of course, we have to handle the error because this URL might be null in many different scenarios that I discovered afterwards, and that led to data inconsistency, but that's another story. So basically, if the user has iCloud full, this will be null. If I don't know, if they disable the syncing in the settings, this will be null, or network is missing, this will be null, or things like that. So yeah, end of the error because it will be fun. Second, another thing, it's we have to remove the file inside iCloud, because if we call the copy method won't replace the file, but it will be just keep adding the file with parentheses 1, 2, 3, 4, and whatever. So that's something that it was fun to discover, and you need to do. And in this case, I'm ignoring the error because, yeah, it's just a best effort action. But now we want to handle the error. So in order to handle the error, we need to open a memory scope, because that error that you pass to those APIs is actually a pointer to an error, not directly an error. So we need to allocate a pointer, and basically we can pass the pointer to the function that copied the file. So in this case, this copy item at URL, it can just copy from our source, so the database path, to the destination, which will be the iCloud URL. And we can pass the pointer, and then after that, we can check if the pointer is not null. If it's not null, then something bad happened, and we have to handle the error, basically. And that's it. That's the whole code that you need to upload something from the local storage to iCloud in your machine. And that works, that is now it's for macOS, but it works also on iOS, because it's the same code that works in both situations. Okay. However, it's not enough, because we need to tell the JNI how to connect the dots and just go into this file. And the funny thing is that the dynamic linking that the JNI does when you interact with it is based on the names that you give the function. So luckily, on Kotlin native, there's this CNAME annotation, so you can customize the name that the method will have when it's going to be exported in the library. If there wasn't the CNAME, you have to call the method with that long blob of text. So luckily, luckily in Kotlin Native, we still have a manageable and proper name for a method, and then just having the native library is something that we don't care, and the machine will care, and so we can live our happy life. Okay, so how this blob of text looks like. Basically, there's a predefined structure that we need to follow. The first one is a prefix that is just Java underscore. That's by default, we have to have that. Then there's the fully qualified name of the class that will contain the methods that we are going to use. And we're going to see in a second what this class means. But basically, it will be the fully qualified name with the package name and the class name. Of course, mangled, because we cannot have dots, but we replace dots with underscore. Then another underscore, and then the method name that we want to actually use. So this structure will be the ugly method that is going to be used, and that the JNI will use to connect the things. Okay. Last step is having the actual connection. So we need an actual class and piece of code that we can call inside our Compose Multiplatform app in order to interact with the JNI. So how we do that? We can create a class, and then we have to list the methods like if it was an interface, so that the JNI will know not the JNI, sorry, but the JVM will know that the implementation of this method will be inside the JNI and inside the native libraries. And that is made possible by marking the thing with marking the method with the external keyword. So in this way, we can instantiate the class, call the thing, and then the magic will happen. Okay. At this point, we wrote the code, and it's time to build finally the actual native library before having it into our macOS app. So to build the library, there's a Gradle task that we can invoke that is called link release shared iCloud in this case. If you have a library with another name, which probably you're going to have, then the suffix is the only thing that will change. And it will change based on the name that you gave in the Gradle configuration. There's also a link debug shared iCloud if you want to build with the debug symbols for debugging. But yeah, in this case, we're directly with the release one. After you invoke this task, our dynamic library that is called dylib will be placed inside the build folders of our project, and then we can bring that library and put it into Compose Multiplatform. So we have to bundle it together. And this step is important because we have to bundle it in a way that will be signed, that the library will be signed together with the app. Because when you're publishing an app on macOS app in the Apple Store, your library needs to be signed. Otherwise, with your certificate from Apple, after you pay your fee to Apple. If you don't release it on the store, you don't have to do that. But yeah, it's a good practice to bundle it together. So to bundle it, likely there's functionality provided by the Gradle plugin of Compose Multiplatform. So we can have some folders in our Compose Multiplatform project, and those folders can be OS and architecture specific. So like in this case, macOS ARM64, so only for Apple Silicon. Otherwise, you can have it only for a specific OS, Linux, Windows, or whatsoever, or even common if you have common resources that doesn't have to be native libraries, but could be any kind of resources that you need in your app. And after that, you have, of course, to inform Gradle and the Gradle plugin where that library is. So you can have whatever folder you want to call it, but you have to set the app resource root directory in this way. And by setting this, when you're going to build your app, the library will be bundled together, signed if needed, etc., etc. So it will be together with the final application. OK, now that we have it together, we can finally load the library and use it. So to load the library, we have to find where the library is. And at runtime, we can know that path by accessing the property that is Compose Application Resource Directory, which is the one that we just set. And we get the path at runtime with this property. Then we have to actually build the library path, and the library will be in the resource directory. And then we can get the name of the library with this method that is map library name, iCloud, and then we pass the name of the library. And this method will automatically resolve the name, which usually will be with a prefix lib. So the final name will be lib iCloud, but to avoid typo, there's this method, so we can use it and we can profit from that. And at this point, we have to actually load the library into the app, so we can use the load system.load method that will load the library. And of course, since it's the JVM, we have to try catch everything, because with the loading library at runtime and things like that, things can go south. So look for the satisfied link error, because could crash. So just not explode the app. OK. And finally, it's time to profit from all of those things. So in your app, you can just instantiate the class that we created before with the external method and call the method. And then if we didn't mess up during linking and during the loading, everything will work, and you're going to have your database uploaded to iCloud magically, which is amazing because it was done only with Kotlin. OK, let's try to wrap things up. There's some additional complexity into the process, because there's a bunch of things that you have to set up. The learning curve is also, there's a bit of learning curve, because you have to understand how the JNI works, how to bundle together, how to set up things, and all the interconnection. But in my opinion, it's all worth it to just avoid writing Objective-C, because it's not the most beautiful experience. But after you dealt with this thing, then you can have the full power to just be able to connect the dots and go above beyond the JVM, and then access whatever native APIs you want to access. For example, it's not, of course, the iCloud was a perfect example, but you can also call something else, like, I don't know, you want to have in-app purchases on a macOS app with Compose Multiplatform. You need to access StoreKit and do things in there, so maybe you can do it in this way. Or, I don't know, every other APIs that are macOS specific and not exposed by the JVM. And another suggestion that I want to give you is to keep the API surface as simple as possible on the JNI part, because you have to deal with things, and there's complexity into doing stuff inside the JNI. So keep it simple. So for example, if you have to return errors or things like that, just return an int, and then map that int on Compose Multiplatform or in your Kotlin code outside the JNI, because yeah, it's gonna be easier to not have to instantiate things on the JNI and have to deal with passing things around. So yeah, keep it simple, and it's gonna be better. And yeah, all of those things, and by the way, I didn't get that additional star that I was looking for, so yeah, the user didn't update. After getting iCloud, getting myself into the JNI, I didn't get the star that I wanted, but yeah, that's another topic. Yeah, so by the way, all the stuff that I said today, I wrote also an article on my website, so that goes step by step in these things. So if you want to catch it up, there's also a link to the PR of the actual iCloud implementation that I did, so you can check it out, because yeah, FeedFlow is open source, so you can check it out. Yeah, that's it. Thank you very much. I hope you enjoy it, and if you have any question, I'm here to listen. So yeah, thank you.